Let's assume that the given triangle is ABC. Let's assume that the shortest side is BC, is therefore equal to 1 as per the problem statement. The angle opposite it is angle A, which is equal to 30 degrees. Let's assume that side AC is equal to root 2 and that side AB is equal to C. Now drop a perpendicular from the vertex B onto the opposite side AC, and let's assume that the foot of the perpendicular is N. Now in triangle ABC, we know that cos of A is equal to B square plus C square minus A square upon 2BC. A is equal to 1, B is equal to root 2, and the angle A is equal to 30 degrees. Plugging in these values, we get cos of 30 degrees is equal to 2 plus C square minus 1 upon 2 root 2 times C. Cos of 30 degrees is equal to root 3 upon 2. And therefore, we have the equation root 3 upon 2 is equal to 2 plus C square minus 1 upon 2 root 2 times C. Cross multiplying, this becomes root 6 times C is equal to C square plus 1. Moving all the terms to the left hand side, we have the quadratic in C. C square minus root 6 times C plus 1 is equal to 0. Solving for C, we get root 6 plus minus square root of 6 minus 4 upon 2, which simplifies to root 6 plus minus root 2 upon 2, which is equal to root 2 times in brackets root 3 plus minus 1 upon 2. Therefore, C can hold two values which are equal to root 3 plus minus 1 upon root 2. Now, the area of triangle ABC is equal to half of the base AC times the perpendicular BN. Now, the base AC is equal to B, which is equal to root 2, and BN is equal to C times sine 30 degrees. This is equal to 1 upon root 2 times C upon 2, or C upon 2 root 2. Now there are two possible values of C derived earlier. When C is equal to root 3 plus 1 upon root 2, the area of the triangle A1 is equal to 1 upon 2 root 2 times root 3 plus 1 upon root 2. And when C is equal to root 3 minus 1 upon root 2, the area of triangle ABC, A2, is equal to 1 upon 2 root 2 times root 3 minus 1 upon root 2. Therefore, the ratio of A1 to A2 is equal to root 3 plus 1 upon root 3 minus 1. Now, applying sine rule in triangle ABC, we have sine A upon A is equal to sine B upon B. Since angle A is equal to 30 degrees, side A is equal to 1 and side B is equal to root 2, we get sine 30 degrees upon 1 is equal to sine B upon root 2. Therefore, sine B is equal to root 2 times sine 30 degrees, which is equal to root 2 times half, which is equal to 1 upon root 2. Therefore, angle B is equal to 45 degrees. Since the sum of the angles of the triangle is 180 degrees, angle C is equal to 180 degrees minus the sum of angles A and B, which is equal to 180 degrees minus, in brackets, 30 plus 45. And this is equal to 105 degrees, which is the required answer.